Okay, so this is 13.2, but normally, right, you'd start with 13.1. If you were taking AP Calc, this part would come first though, so that might be why I'm a little bit biased, but I do think it's better to see 13.2, which is called an indefinite integral, so that part's right here, indefinite integral, because 13.1 is a definite integral, okay? So, before we get too far, integration is the opposite of differentiation. Okay, it often gets stated as three different things. Any ways you've heard this said? From friends or otherwise? Asher?
Can I get a pencil?
Can you get a pencil? No, that's not one of the words for integration.
Area under the curve.
There you go, area under the curve. So, area under the curve. So right there is area under the curve.
Your pencil, buddy.
And that's good to know because you'll see that, like it's going to put that in the phrasing, and then that's going to tip you off, okay, I need to use this next word, which is what I was just going to say. So I need to use an integral. Okay, so if it says find the area under the curve, you know that you're going to take an integral of something. And then the last part is kind of this one word for this, reverse of differentiation. That's just often called the antiderivative or antidifferentiation. So antiderivative is the process of integration. Okay, so I kept this graphic here. This is the start of 13.2 in your book. But what you see right there, that is a definite integral. So the shaded piece, that part, is the area. That's what we're finding underneath this curve. And in particular, our curve is modeled by x squared plus 1. Okay, but the reason why it's a definite integral is because it has a lower bound, meaning it gets stopped on this left side, so 1, and it gets stopped on the right side, 3. So the way that it would get written in 13.1 is the integral from 1 to 3 of that function. Okay, that's a definite integral, and we can find, and we will find, that area right there, and we'll have a numerical value which gives us that. Okay, so that's what we do in 13.1, but that's the process, or what that looks like, finding the area under the curve. But 13.2, which is what we're doing, is just going to be a indefinite integral, so we don't have any minutes. Yeah?
So we're not going to learn how to do that?
No, we are, so that's in 13.1, but you can do that in different videos.
Oh.
Okay? Okay, so that's from 13.1, but that's not quite what we're doing today. Okay? But just check this out. This is the same graphic, except for it doesn't go all the way up to 3. But what this box is telling you is as you go further, more and more towards 3, is there getting more and more area under that curve?
Yeah.
Right? So that's all that's saying. So as x is getting closer to 3, you're calculating, finding more and more area, because there's more that's there. Okay? And then similar graphic is right here, is now the function's different. It's not that same function, but you might have a function that looks like this, and you start at some value A, it could go all the way up to some value B. As this gets closer and closer to B, you're finding more and more area. Okay, so as long as you're taking as much of the area as you can, you've found the most. Okay, so these are just kind of some things coming from 13.1, but not really what the point of 13.2 is yet. All right, this graphic's a good one. All it's telling you is if you take an integral of a derivative, you're just going back to the original and so on and so forth. So, notation-wise, this is our function, f of x. If you take the integral, the antiderivative, you notate that with capital F of x. So if you have f of x or g of x or h of x, whatever it is, if you take the antiderivative, it goes to its uppercase to denote its antiderivative. Okay? But then if you take the derivative of that, it just takes you back to the function. Okay? So those two processes can just undo each other. All right? And then, again, just let's get some notation and some vocabulary there. So if we're finding the integral from a to x, then our lower bound is a, our upper bound's x. This part right here, that little stretched out s, that's called the integrand. So that symbol is called the integrand, telling you you're taking the integral or the antiderivative. And then whatever you have here. So this says f of t dt. If it was the function in terms of x, you'd say f of x dx. If the function was in terms of, I don't know, y, you could say f of y dy. All right? And then let's skip that part because that's referencing 13.1. But again, just for notation's sake, capital letter F is the antiderivative. So if you take the derivative of that, it just takes you back to the original. Okay, so they're just undoing each other, antiderivative or antidifferentiation.
Sorry.
Yes?
Are we supposed to have learned 13.1?
No, you'll do 13.1 after this. Okay? But now this is kind of what our main takeaway. So go to the back part. And in IB, right, we only get two very small calculus units. So this one is our main piece. And it's easy because the only way we took a derivative, the only way we know how to take a derivative is by using the power rule. So this is the power rule in the opposite direction. Okay, so let's look at this and then we'll show it and you'll see that it's pretty straightforward. This says if we take the integral, notice this is an indefinite integral. There's no lower bound, there's no upper bound. So it's just saying the general antiderivative of some function that has a as a constant raised to x raised to some power. Okay? The way that you do that is right here. A times x raised to the n plus 1 divided by n plus 1 and then plus c. Okay, so let's talk about those two pieces. Can you put this first piece in your own words? What could you say is happening right there? Could you just put it into words if you were describing what that says?
What did you say?
What would I say? Anybody want to try it?
What are you saying right now?
What did you do from here to here? Compare that to that. What did you do?
Plus 1.
To what?
To the exponent.
To the exponent. And then divided by what?
That again.
That exponent. Okay, so that's what I was trying to get us to say.
Oh, sorry.
Add 1 to the exponent and divide by the new exponent. That's the power rule in reverse. So if you want to write that in, so add 1 to the exponent. Then divide by the new exponent. And little phrases like that, when you take calculus, you have those types of phrases for lots of different things. So, but let's say it again. Add 1 to the exponent, then divide by the new exponent. Okay, and then, so that's this piece right here. And then we have this plus c, which just means you have to add some constant value, okay? And it says that right there. Okay, so this is an integration rule for the power rule, and that's all you have to do. You don't have to do there's product rules, chain rules, quotient rules, there's trigonometric rules. We don't have to do any of them. The only rule we have to focus on is the power rule. So this is going to be the only way you're ever asked to find an integral for this class. Yes?
How do you know what C is?
How do you know what C is? We'll talk about that, okay? And you have to have a few other things. But that is actually a great question. So how do you know what C is? Well, let's address that. Let's say this, okay, f of x. Let's just say f of x is 3x squared minus 7. Because Asher said, well, wait, how do I know what C is? Okay, and often you're just going to write C. You won't be able to know what it is, okay? If that's the f of x, what is f prime of x? What's the derivative of that?
6x.
6x, is that right? Right? 2 times 3 is 6. Raise it to 1 less, that's 6x. Right? The derivative of negative 7 is nothing? Okay, so that's 6x. Okay? So how about this? What if f of x was 3x squared plus 5? What's the derivative?
6x.
Is it 6x?
Success. Yes.
Yeah, it's 6x. Okay? So the derivative of what's written in red and what's written in black are the same thing. Okay? You could just, we could go one step further. Let's say f of x was equal to 3x squared plus 500. What's the derivative of that?
6x.
6x, right? So f prime of x is equal to 6x. Okay? So Asher's question, how do I know what c is a great question. We will answer that in a little bit, but this is why it doesn't necessarily matter in terms of a general antiderivative, because the derivative of all of these functions end up being 6x regardless of what that constant is. Okay? So you can just say, well, I know the antiderivative of a certain function is 3x squared plus something, and I don't know what that something is, but I also don't care because I get the same thing if it's just a general antiderivative. Okay, so we'll readdress C in a second, but let's go ahead and just use that to do the reverse of the power rule on these next questions. Okay, so first one says, find the integral, or find the antiderivative of x to the fifth over 4 dx. Okay, so I could write it like
X
this.
to the 6th.
I'll rewrite it like exactly what we have here. X to the fifth over 4 dx. So the antiderivative of that, add 1 to the exponent, which would give you what?
X to the 6th.
X to the 6th. So this is x to the 6th over 4,
Wait,
right? Because that stays there. That's like that constant. What's your constant right there? What's x to the 5th being multiplied by?
dx. I don't know.
1/4.
Huh?
1/4.
Oh. Oh, wait.
What? How, why did it just magically
I
have
thought you were
6?
supposed to do
Okay.
plus 1 on the bottom.
Hold on. Let me show you this. Let me show you this. Are these two things the same thing?
What?
Do those two things say the same thing?
Yeah.
Yes.
Yeah. Okay. So what we're doing then, if we put these together, then that's going to say, I'll use this one just so we can see it. It's 1/4 x to the 6th divided by what? What's your new exponent?
6.
6.
That's what I was saying. So why was it still over 4?
Okay. So now, what does that equal?
What did,
Yeah. Why is the x so 6 over 6? Yeah, how is x 6 still? How is x to the 6th over 6?
oh.
How is it x to the 6th over 6?
Yeah.
This 1/4 is like a constant, right? So now I'm just taking this x to the 5th. I'm adding 1 to the exponent, which is x to the 6th, and dividing by the new exponent. But I still have it multiplied by this 1/4.
Oh, I just didn't know that new equation. That new
Okay,
equation's weird.
so then what does that equal? Yeah,
Actually, I have a question.
go ahead.
Does dx ever have a value, or is it just simply right?
So dx does not ever have a value. It's called a dummy variable, actually, just to show what you're taking the antiderivative of. It's just notation.
But isn't that what the integral symbol is for?
Yes, but so you could take an integral of a function that has more than one variable, so that tells you what you're integrating with respect to. We will only do one variable, so it's always just going to look that way. Okay. So what does that equal?
X to the 6th divided by 24?
X to the 6th over 24.
Oh my gosh!
X to the 6th over 24, and then I need to do this. Okay, and you will miss the question if you don't do this. You need to say plus some constant, plus c. We don't know what it is. We don't have enough information to even find what it is. We'll see what it looks like when we do, but that is what that ends up equaling. X to the 6th over 24 plus c. Okay? Let me just show you that in reverse. So now, let's say our function, let's say f of x is that function. X to the 6th plus over 24 plus some constant, which we don't know and we don't care about. Let's find its derivative. F prime, right, would be bring the 6 down in front, raised x to the what?
Wait, why are we doing this? This is the question?
No, this is not the question. I'm showing if we took the derivative of this, will we get this? So,
Oh. I get it, bro.
Okay, so the 6 comes down in front, I raise it to 1 less, and this 24 is still there. Okay, what cancels there?
6 and 24.
6 and 24. This 6 becomes a 1, take a 6 out of here, that becomes a 4, and you're left with x to the 5th over 4, which is that.
That's why it's called antiderivative.
That's why it's called the antiderivative.
Dude.
What's the derivative of this c?
Nothing.
0,
Nothing.
so that's why there's nothing there. Okay? Okay, let's do the same thing here then. So if we're finding the antiderivative of that, okay, there's how many terms do we have? 3. So let's do term by term. So add 1 to the exponent, x to the 3rd, over 2, divided by what? Add 1 to the exponent and divide by the new exponent. What's your new exponent?
Oh, 3. You just did that. 3. Oh, divide by 3.
Divide by 3? Okay.
But times it by 2, so it's 6.
Yes. So I think we're getting confused by fractions. I'm going to show it like that.
Oh.
Okay, what Bethany said is right. But
Oh.
x to the 3rd over 2 divided by 3. Okay, but dividing by 3 is the same as multiplying by what?
1/3.
1/3. So if you multiply this by 1/3, what do you get? X cubed over 6. Which is what Bethany said. So x cubed over 6 is that first term. Now let's do this term. Add 1 to the exponent. That would give you what's your new exponent? 2. So it would be plus 3x squared divided by 2. Add 1 to the exponent, divide by your new exponent. That's 2. Okay? What's the exponent of this 1?
Well, isn't it just going to be x?
Yes. For what reason? What's the exponent of it right now?
0.
This is like saying this, right? Negative 1 x to the 0. Because what's x to the 0? 1. So what's our exponent of 0? If you add 1 to it and divide by the new exponent, it would just be x to the first divided by 1. So it just becomes negative 1x, or just negative x. Okay?
It's the opposite.
So, yeah, it's the opposite of the derivative. So the antiderivative of a constant is just that value times x. Okay? So negative 1x. Okay? What am I forgetting here? Plus c. Plus some potential constant that we don't know and we don't have enough information to find. So the antiderivative, the general antiderivative, the indefinite integral of that would be that value right there, or that function right there. Okay, again, we're not going to do it, but if we took the derivative of this, we get that. Okay, so if you take a look at that, you can probably see that. Yes?
Why wouldn't x to the 0 just be 1?
X to the 0, so this is 1, so that's why negative 1 times 1 gets you negative 1.
Okay, so why is the negative x here?
Because if we added 1 to that exponent, it would be x to the 1, and then you divide by 1, so x to the 1 is that.
Oh, okay.
So that's what's happening there. Okay, so same idea here. So maybe it might be nice to rewrite this one like we did when we were doing derivatives. I'm going to just rewrite the integral and say, do these two things say the same thing?
Yeah.
Right? X squared in the denominator can become x to the negative 2.
So,
Okay? So now I do the same thing. Adding 1 to that exponent would give me what?
negative 1.
Negative 1. So I keep the constant, which is 4. The constant comes along for the ride either direction. So 4x to the negative 1 divided by what?
Negative 1.
Negative 1. That's your new exponent. And then I need a plus c. Okay? Now I just need to clean this up. 4 divided by negative 1 is just negative 4. And then I could write it
It's
as
gonna be
negative
negative
4x to
over
the
x
negative
to
1.
the-
But x to the negative 1 we want to write like that, right? Put it
Yes.
back in the denominator, make it positive. Plus c. So the integral, the indefinite integral, just finding an antiderivative of that function would be negative 4 over x plus c. Okay?
Is this all that 13.2 is?
It's mostly it, okay? So here, just do one more on your own. Let me just make one up. So find the integral of 3x to the fourth minus 2x cubed plus 7x squared minus 4.
Why are we doing crazy style now?
That's not crazy.
This is not even crazy because there's no
It's easy. It's actually easy. What's the antiderivative of that? Go ahead and try to find it.
Snyder.
Yeah.
So like what we have to do if we like bring this down minus this by 1 first and then see the interderivative, or we just do it right away.
You just do it right away. You don't take the derivative before you do it. Yeah.
student still is that doesn't true.
Go for 20 more seconds.
So what do we do down here with the 4 of these?
They're just 4. The antiderivative of a constant is always going to be that number x.
Okay.
That's right.
Why does this look so much crazier than like normal? Like
Part of it's the notation. Like you've never seen this integral before, and everybody's like, "Oh, that's a crazy looking thing." It makes
No, I swear, like when I do derivatives, I get these numbers all the time, but it never is like. I don't
well,
know.
but now you're doing an antiderivative.
I know, but
Okay.
it's like now we're finding like the original equation.
Yeah.
But like, I swear I get like these numbers all the time, and they're never fractions. I'm just like.
Yeah, there's a few fractions put in here on purpose to make you think through what's happening there. But yeah.
Well, no, never mind. I'm
You
just.
sure?
Yeah, well, when I'm doing homework and I find a derivative, I get like something like negative 2x to the third or something.
Yeah.
But it's never originally a fraction.
Well, because you're going in the derivative direction instead of the antiderivative. If you were taking the antiderivative, you'd probably get a fraction, or
Okay.
you have the potential to get a fraction. Yes.
I get it.
What do I do from here?
Let's just go through it, and then you can ask that same question. So let's go term by term. I would add 1 to the exponent, which would make the exponent what? 5. This constant, the 3, comes along for the ride. So 3x to the 5th over what?
5.
5, the new exponent. Okay, I keep this symbol the same, so minus. This 2 comes along for the ride, so 2, x to the what? 4th over 4, the new exponent.
And that can be simplified. By
Yeah, and we'll clean that up at the end. Okay, and then this goes, so plus 7 comes along for the ride. X to the cubed over 3. Okay, and then the antiderivative of a constant is just that number
Multiplied by x
multiplied by x. So negative 4x. And then what do I need?
plus c.
Plus c. So if you find a indefinite integral and you don't put the plus c, they're actually just going to mark you
0.
wrong. Okay? So make sure that you have that. Okay? And then the only other thing you'd want to do in this case is just simplify any fraction. So the only fraction that can be simplified is this 2 over 4. So you could just make that x over 2. Okay? So that would be your antiderivative of your indefinite integral. And again, it's an indefinite integral because we don't have a lower and upper bound. If we had a lower and upper bound, it's a definite integral, and that's 13.1. Okay, questions about what you see there?
No.
Let's do this second example, and we've been putting plus c. Asher said, wait, how do I find c? And so here's the first time we're going to be see how we can do that. All right, so let's check that out. The questions look a little different too, but that's the point. You have to have some additional information. So the curve y equals f of x, so some function, passes through the point 1, 3. The gradient tips you off to, it's the what? Derivative. The gradient, so that's the derivative. The gradient of the curve is given by that, and then they do you a big favor. They tell you the gradient, and then they also just tell you that's f prime. A lot of times they won't do that, okay? So, and then find the equation of the curve. So it wants the original. So do you agree with this statement? If we have the derivative, and we're trying to find the original, we're finding an antiderivative, right? That's the direction we're traveling. Okay, so that's what we need to do. So then, here's the thing. Could we do this just like we did the last few examples? Yeah, we can find that integral. We'll show that. So this is going to be an integral. And then this right here, this is important. If you're going to be able to find c, you have to have some type of an initial condition. So you have to know something about a value of the original function, okay? And they tell you the curve, the original, passes through that point. So that gives us a value for our original function, okay? So if you're gonna find a value for c, you have to know something about an initial condition, all right? So here we go. Let's take it from here. Here's what we're being asked to do. We're asked to find, we have the derivative, we want the original, so we're finding the integral of 2 plus x over 3, you can put that in parentheses if you wanted, dx. That's what we're being asked to find, which is exactly what we were just doing on the previous examples. So, let's do it. What's the antiderivative of 2?
2x.
2x. Now I have a plus sign, plus, add 1 to the exponent and divide by the new exponent. So adding 1 to the exponent would give us what? X squared. There's already a 3 on bottom, so if I divide that by 3, you're essentially multiplying that 3 by 2, right?
Yeah.
Or whatever the exponent was, which is 2 in this case. And so 3 times 2 is 6. And then plus c. That's what? The original equation, okay? And I kind of don't love the way they did this because they gave us f prime. So the antiderivative of f prime is actually just going to be f of x, okay? But if they would have given this as f of x equals, then the antiderivative of f of x would be capital F of x, okay? But we just took the antiderivative of the derivative, so this gives us f of x. Okay, so we just found f of x.
Wait, I thought you said we would find the c.
Yeah, so now Bethany said, wait, you just said we were going to find the c. So, any thoughts? Yeah.
So we just plug in the x value of the point it gave us,
Yes, and?
and then the y, make it equal to 3.
Beautiful.
Wow.
This is an x value.
Stunning.
This is a y value, which the y value is this, yeah? Okay, so we can just plug in our initial condition. So x is 1, so it looks like this. 2 times 1 plus 1 squared over 6 plus c is equal to the y value, f of x, which is 3. Henry, we don't need your sidebar.
Okay.
Okay, so now we have this. 2 plus 1/6 plus c is equal to 3. What do you want to do with that?
Subtract. Wait,
Sub-
yeah.
Subtract what?
What? I didn't get it yet. I'm fine.
What'd you say? 2 and 1/6, right? 2 plus 1/6 is 2 and 1/6, so we can just say, okay, I gotta subtract 2 and 1/6 from 3. What's 2 and 1/6 minus, or what's 3 minus 2 and 1/6?
5, 6.
5/6. So c is equal to 5/6. Okay, so it says, find the equation of the curve. The equation of the curve is this, and we replace c with 5/6. Okay? You'll very likely have a question like that on the exam. Okay, so again, the function, the original, we were able to solve for c. How were we able to solve for c? We had an initial condition. If you don't have an initial condition, then you cannot solve for c. Yes?
So if there was a question like this on the test,
Yeah.
and it
I'm just gonna say yes, because I don't think they'd give you an initial condition if they didn't ask you to do that. Okay? Alright? But it might part you out, like find the indefinite integral, and then it might say, if the curve passed through this, now find the function. It might do it like that way. Okay? Okay, so A and B are the same question, just phrased or the information given to you differently. If dy dx, right, that's the derivative. If dy dx is this, and we have a y value of -1 and an x value of 3, that's just a different way to say essentially the curve goes through there. We're just saying this is our x value. Find y in terms of x. So the antiderivative of dy dx is going to be y. Okay, so essentially, if we set this up as an integral, I'm going to write it over here because I want to come back. We're essentially doing this. We're finding the integral of 2x minus 4x squared dx.
So this is B.
Okay, that's all we're finding. Yep, this is b. Okay, but I'm going to show it right here. I just said this. What's the antiderivative of dy dx?
Y.
Just y. This is y. Okay, what's the antiderivative of 2x? Add 1 to the exponent and divide by the new exponent. So let me show you. That looks like this. 2x squared over
So you
2.
can just cross those out.
Yeah, and we'll cross that out in a second. Let's show it all first. Okay, now this one, minus, the 4 comes along for the ride. X to the what?
Third.
Third. Divided by what?
3.
3. Am I good there?
Plus C.
Plus C. Right now, it's plus C. Okay, so that would be the integral right there. Okay, yes, we can clean this up. Let me just write it. Y is equal to, those cancel and you're left with x squared minus 4/3 x to the third plus C. Okay, we want C, and we have an initial condition. We're just told y is equal to -1 when x is equal to 3. So we can just plug x is 3 and y is -1. So that looks like this. -1 for y, x is 3, so that's 3 squared minus 4/3 times 3 cubed, plus c, which is what we're solving for. Let's show it. This is -1 is equal to 9. What's 3 cubed?
27.
27. What's 27 divided by 3?
9.
9. 9 times 4, -36, yeah? Did I lose anybody there?
Yeah. I'm lost.
3 cubed is 27. 27 divided by this 3 is 9. 9 times that 4 is 36. Okay? If you put that into the calculator, that's what you would get.
I'm just kidding. I just.
Okay? So then we have this. We have -1. Sorry, it's a little messy there. 9 minus 36 is what?
I don't know.
9 minus 36?
-27.
-27 plus c. I'm just trying to get c by itself. I'd add the 27. Add the 27, and -1 plus 27 is 26. So in this case, c is equal to 26. So if I put all of that together, it says find y in terms of x. So we want an equation for y. We basically have it right here. Well, actually this one that's written in black, we just want to put c in. So I'll just take it from here, and I'll say, okay, y is equal to x squared minus 4/3 x cubed. What?
Do you have? Would you?
Plus 26.
Would it be better to write it as 4/3 x cubed or as like 4x to the third of?
Yeah, I was just going to say that. So the only thing I don't love about this is if you're writing it in standard form, this should be your first term listed, right? So you would just rewrite that as -4/3 x to the third
Can't leave all that.
plus x squared plus 26.
That's so much sense.
Okay?
That's not.
Yes.
So, is it different when it's 4x to the third divided by 3?
No, but it's just written differently. But do you have to write it like that with fraction first?
Oh, are you saying, is this different than that?
Yeah.
No, I just,
Okay.
But
it,
like,
it says the same thing.
do you have? Can I write it like? the
You,
first one?
this is not any more preferred than this one. So
Okay.
whatever you like works there. Okay, questions about what you see there? So again, the only way you can ever find a value for the constant for C is if you have some type of an initial condition. So that was our initial condition, and then this was our initial condition. We kind of got those in very similar ways. One was an ordered pair, and one was just this is y, this is x, and that is your initial condition. Okay, let's do one more. I had to put this on there because we don't normally say this in the US, and so I would be bummed if you got this, and you would probably be bummed because IB does this a lot. So let me just show you this terminology. It's super easy, but if you've never seen it before, you're going to be thinking, I don't know what that means. So, let's see it. And you'll see this in your practice a little bit. So last example says,
All the right.
and then, well, yeah, let me read it and we'll talk about it. It says, find the cost function, C of x, when the marginal cost is m of x is equal to 1 plus 2x, and the fixed cost is $40 US. Okay? So we got cost, we got marginal cost, and we got fixed cost. And most of us are like, what just happened right there, right? So, first of all, cost, I think we understand. What does something cost? Okay, marginal cost, we saw this on a previous question, but it was the cost of producing a single unit of whatever it is you're producing. And then we were told at that time that the derivative of cost gives you the marginal cost. So you kind of want to know that. So cost, its derivative, gives you an equation for marginal cost. Okay, so maybe just write that down or put that in your brain
So
because
marginal cost is the derivative?
marginal cost is the derivative of cost. Okay, and so if you don't know that, this question is very confusing. So that's one of the things you need to know. Okay, and then this concept of the fixed cost, that's not a term we use much. The fixed cost means that's going to be the cost when we've produced nothing. So when x is 0. So basically this is saying
That's
fixed
fine.
cost, x is 0, y is 40.
How do you buy something that's nothing?
Well, it's so this would be modeling the cost of maybe producing something. So to keep the lights on and the machinery running, it's $40 or whatever the situation might be.
Okay.
Okay? So what we have is we have a derivative, and this fixed cost is our initial condition. Okay? But that's the part we have to connect. So we want a cost function, so we are essentially going to find the antiderivative of the marginal cost. So 1 plus 2x dx. If we find the antiderivative of marginal cost, we'll get the cost. If we know the relationship between those two things are marginal cost is the derivative of cost. Okay? So let's just show that. The antiderivative. What's the antiderivative of 1? X. What's the antiderivative of 2x?
X squared.
Is it just x squared? Because it's 2x squared divided by 2, which gives you x squared. Did I lose anybody there? Okay. And then I need to tack on my what? Plus c. Okay, and then again, this part right here, fixed cost, that's what it's going to cost without producing anything. So this is basically saying C of 0. C of 0 is equal to 40. That's what a fixed cost is telling you. If the fixed cost was 500, C of 0 would be 500. Okay? So then if you plug that in, it's always just going to give you the constant. So it just like it's handing you the constant because what you have is this, right? This is, we just found this to be the cost equation, right? And so if we plug in 0, it's 0 plus C is equal to 40, which means C equals 40. Okay? So C is equal to 40, making our cost equation exactly what we see right there. Let's just rewrite it. And I'm going to rewrite the x squared first. So x squared plus x plus 40. That's our cost equation. Yeah, so here's the thing. This is a super easy question, but if you've never seen that, which I don't think any of you have seen that terminology, you get that on the test and you think you're doing something special or you don't even know what you're doing, right? But that's actually a pretty easy question.